let's take a look at how to determine whether an equation, a function, is an even or an odd function. One way we can do this informally is to look at a graph and see what kind of symmetry the graph shows. Now, this won't prove that the function is even or odd, but it'll give us some evidence and maybe some information when we go to prove this algebraically at the end of the video. So you'll notice with all three of these graphs on the screen, all of them are symmetrical about the origin, meaning sort of this piece up here is always going to be sort of a reflection of what you see down here. It's not really folded over this line, although I like to kind of think of it that way. Same goes for all of these. They're symmetrical about the origin. Whatever is on this side is reflected sort of reversed or sort of rotated down into that section. All of these show origin symmetry, and so all of them have evidence, or there is evidence that these would be odd functions. Easier to remember it if you see origin symmetry. It's possibly an odd function. On the other hand, if we take a look at these three graphs, all of them show y-axis symmetry. We can fold them along the y-axis, the vertical axis, and all of them are symmetrical about that. This provides evidence that the function is going to be an even function. Again, doesn't prove it, but there's evidence there for it. So that's one way we can do it informally, but let's go ahead and take a look at how to do this algebraically. And so what we're going to do is replace every x that we see with negative x, or the opposite of x, and just see what happens. So for example, this first graph, or this first function down here, x squared minus 5, I'm going to replace this x with a negative x, and then just rewrite the function. So negative x squared minus 5. Notice I put it in parentheses. I always want to do that. And let's take a look and see what's going to happen right here. Well, we don't know what x is, but if I take a negative number and multiply it by itself, square it in other words, I'm always going to get a positive answer. That's true if I raise that to any even power. And so this first piece is just going to work out to be x squared. It'll always be positive, and then that minus 5 just stays what it is. So if you take a look at where we ended up compared to where we started, we ended up in the exact same place. They're identical. And so this is our first sort of algebraic proof down here that if we end up with the same function when we replace with negative x, that is undeniable proof that the function is going to be an even function. If you think about the graph of what this would have looked like, it's a parabola. So it would look roughly like this, which we said, well, an even function would have y-axis symmetry, and yes, sure enough, that would have y-axis symmetry. Okay, let's take a look at what's going to happen on this next function. Once again, to determine whether I'm even or odd, replace x with negative x. And every single one, so minus and then a negative x back here, and let's see what happens. Okay, this time I have negative x, a negative number, raised to the third power. Well, if I multiply a negative number times itself 3 times, I'm going to end up with another negative number. So whatever in those parentheses will make this whole first piece negative. So I'm just going to put it in front and just say negative 5x to the third. The second part, since I have minus a negative x, I'll just change that into a plus x. And I can see that this is not going to be an even function because I don't end up with the same thing. In fact, if I compare my answer with where I started, I ended up with something that's exactly opposite in every way of where I began. So if this happens, we end up with something that's opposite. Every single sign is opposite of where we started. That's going to be undeniable proof that you have an odd function. Once again, it's kind of easy to remember because if we end up with an opposite function, we have an odd, we'd call it an odd function.